we are with Unit 4, Lesson 7, Homework Help. Let's begin. The first thing we're looking for is we are supposed to select if each of these equations is always true or never true. Remember, always true has infinite solutions, whereas never true has no solution. It can be never, ever true. So the way we look at that is we always have to consider the coefficients of x, or talk about the variables first, and then talk about how that variable is affected by the constant that's at the end. So when we look at A, we see that the variables have the exact same values. But then when we look at the expression on the left, we see that we're taking away 13, while on the right, we're increasing by 1, which means we're not actually changing those variables the same way. That tells us right there that our first selection has to be no solution. Probably a never true. Let's see what those options are. And we see that that one is, let's go ahead and clear that so we can see it. This one is never true. Okay, so that's what we're looking for, never true or always true. When we look at the next one, we're talking again, looking at the constant values, or x. But when we look at the constant values, the coefficients of x are both 1, so x is going to be equal. But here on the left, we're constantly adding a half, whereas on the on the right, we're taking away a half. So that tells me right now that this one again is also never true. But what happens when we get to something like this, where we see that we have a variable expression that is set up with parentheses? Well, then we need to make sure and simplify that first. 2 times x plus 2 times 3, which is 6. And then we need to consider how that is working over here on the other side, looking at the like terms. 5 times x minus 3x is a 2x plus 6. We see that those expressions are exactly the same, so we know this one would be always true. D and E, they're on your own. Give it your best roll. Number 2, if I can get the right button. Here we go, number 2. Let's talk about May says that the equation 2 times x plus 2 is equal to x plus 1 has no solution, because the left-hand side is double the right-hand side. Complete the statement about whether you agree with May. Let's think about the things that have to happen. In a no solution, we have to be able to eliminate the variable so that we can compare the constant values. If I eliminate the variable from the right side, and I do the same thing to the left side, I'm left with x plus 2 is equal to 1. My thought on this is I can keep going. I still have a variable. I have an x variable that's there. The only way that I could tell if there's no solution is if this didn't exist, because then it's a false statement. The other thing that I can look at with this is I can consider that piece where the constant value, or the coefficient of x, is 2 over here and 1 over here. Those coefficients are different. And from our lesson, we learned that different coefficients automatically means one solution. So try the next one. Here in the next one, it says select the other side of this equation so that it is always, or so it's true for all values of x. On these two, what we want to look at again is compare the constants, compare the coefficients. Make sure that we understand those. What I will tell you from the very beginning is simplify first. These are both the exact same expressions, so when I simplify down here, it's the same for both. 1/2 of 6x is 3 times x. 1/2 of 10 is minus 5, and then we see another minus x. Combine the like terms, the 3x and the minus x. 3 times x minus 5 is going to give us 2 times x minus 5. So when I simplify the expression that's given, that's what it simplifies to. Let's compare what we have. We have 2x minus 5 and 2x plus 5. Make sure that you're choosing the appropriate one that's going to tell you whether that's true for all values of x versus true for no values of x. Number 4, here's an equation that's true for all values of x. We're saying it is true. And Elena saw this equation and says that she can tell that this new equation right here is also true for all values of x. So what we need to figure out is you need to tell, for me, simplify the expression here on the left, right here, and then simplify the expression on the right, and then decide, is that enough evidence to prove that we have an infinitely many situation here? Number 5, you have an opportunity to talk about what was Elena's first step. This is review from lesson 4.4. Analyze the equation, take a look at what's different, and decide what did Lynn do first. What you'll notice here is we went from 1/2 times x plus 3 just down to a 3. So how did she get rid of that 1/2? And then when we look at what Lynn did, so that was Elena, then when we look at what Lynn had done with hers, we can go ahead and look and see, and she went from 1/2 times x plus 3 to x plus 6. So we need to decide what she did with a 2. Like, how did she use that 2? Did she multiply by 2 or divide by 2? Okay, and up here, did she add 1/2 of x or subtract 1/2 of x? Number 6, you have a bunch of equations to solve. You'll need to do this on a piece of scratch paper, whatever it may be, but make sure that you're going through and working out each problem and then checking for your solution. I would like to help you with this one right here, just simply because of the fractions, and I still have people concerned with fractions. So what I would suggest to you on this one is a couple of options. I'm going to show you 2 options for how to solve a problem with fractions. Option number 1 is to solve like we normally do, distribute first, and then work off of that. So we have 1/2 of z plus, I'm going to put the line there because I don't want to mistake it for a 2, is equal to 3/2 of z plus, we know that 3/2 times 6 or 1 is 18/2 or 9. So this is plus 9. What I want to do first is I want to go ahead and subtract 1/2 of z from 3/2 of z, which gives me 6 is equal to 3/2 minus 1/2 makes that 2/2. So 2/2 of z plus 9, which is also just 1z. And if I subtract the 9 from this side and subtract the 9 from this side, I get -3 is equal to 1z. So my solution is actually -3. Option 2, let's go ahead and change to blue here so we have a contrasting color. Option 2, 1/2 of z plus 6 is equal to 3/2 times the sum of z and 6. I can get rid of the fraction completely by multiplying the entire equation by 2. So I would multiply the expression on the left by 2, the expression on the right by 2, or I could even just go in here and multiply by the reciprocal of 3/2 to get rid of it, which means I'm dividing by 3/2. So let's go ahead and go that route. Let's go ahead and divide by 3/2. But over here, dividing by 3/2 means that I'm going to take 1/2 times 2/3, which is going to be equal to 2 over 6, which is equal to 1/3. I don't really like that option because I don't want to deal with the fraction again. So let me show you how this other option worked, where I said that I could multiply everything by 2. What would happen here is I would take the entire equation and I'm going to double the terms. In this case, twice the value of 1/2 is just z, 1z, plus twice the value of 6 is 12, and twice the value of 3/2 is 6/2. But because this grouping is inside of the parentheses, it's protected or insulated from multiplying by 2 because it's just the coefficient that's affected. And then what I'm left with is 1z. Sorry, let me get rid of that. I'm left with 1 times z plus 12 is equal to 3 times the sum of 6 and z. And I can go ahead and continue with that process. 3z plus 18, 12, z over here. I'm going to subtract z from here, subtract z from here, giving me 12 is equal to 2z plus 18, subtract the 18, subtract the 18, get negative 6 is equal to 2z. And I hope you can see now that when I divide by 2, z is still equal to negative 3. Just because you see a fraction doesn't always mean that it's going to be a bad problem. This option over here is definitely a lot easier to handle. I think it is anyway. It's a lot easier for me to figure out that z is equal to negative 3 just by doing the way that we've normally done it. Otherwise, there are lots of other options for being able to do this. So, long explanation for something that might just actually turn out to be harder. And the last question you've got is another review problem. It's two parts. First off, answer part A, then part B. So point -3 and 6 is on a line with a slope of 4. Select all the points you would also find on the line. What we would need to do with this is we would have to be able to work through each of these points to be able to figure out what points have a slope when they interact with this point right here of 4. I think that's really hard without having an equation. So what I'm going to tell you is go ahead and answer part B first and then go to part A. So part B, we know complete the equation for the line. Y is going to go right there. And then we need to figure out the y-intercept. With this case, we can't just assume that the y-intercept is 0, 0 because that's one of the options that we're using, saying could this be one of the values? So what we're going to do is we're going to take these values here and figure out what the y-intercept actually is. We have a couple of options for that. The equation is y equals m times x plus b. That's our foundation for this. And what I have with me here is I have the slope m, but I also have values for x and y. So I actually have enough information to substitute into my equation to be able to figure out what b is. I know that y is 6. I know the slope is 4. I'm going to multiply that by -3. And then whatever's left out of this is going to actually give me the value of b. And so when I go to work here, 6 is equal to -12 plus b. I would add the 12 here and here. And I find out that b is equal to 18. So that's my y-intercept. Knowing these values now, what I can do is I can take each of these ordered pairs and I can substitute them into the equation to see if they would come out true. Knowing that this is 18, that automatically gets rid of c because that would indicate a different y-intercept. For the rest of them, I could say for the top one, 10 is equal to 4 times 2 plus 18, which we know is going to be false because that's a positive 8 plus 18 is 26, not going to be true. 14 is equal to 4 times 1 plus 18. That one's also going to be false because that one's 22. But what happens if I take this to -1 and I go with 14 is equal to 4 times -1 plus 18? Well, then 14 is equal to -4 plus 18, which is a true statement. I know this one right here is good. Try the last one and see if letter E works, and that's it for your homework. Have a great day.